As you saw earlier that a Diels-Solder reaction contains two reactants. We have a diene right here and a dienophile. Okay, so we're going to look into the dienophiles first. Now, the dienophiles require an electron withdrawing group. Without an electron withdrawing group, we're going to talk about the electron withdrawing group later, right? So, but let's say you run a Diels-Solder reaction and your dienophile doesn't have electron withdrawing group, the yield is poor. Okay, but once you attach an electron withdrawing group, look at the yield. All right, that's from the textbook. All right, now the electron withdrawing groups are this is an example, right? Examples of electron withdrawing groups. So we have like a carbonyl compound, cyanide, a nitrite group, or a benzene ring. Okay. Now you probably have a question now. So what is the electron withdrawing group exactly? Well, an electron withdrawing group is the substituent that has ability to pull pi electrons. Okay, and for example, if you look at double bond right here, you can draw resonance structures up to oxygen, look like that. So this C double bond O group, or we call carbonyl group, is an electron withdrawing group. The phenyl ring could be in the electron withdrawing group, depends on situation, right? But let's say if that phenyl act as an electron withdrawing group, so you can draw the resonance structure like that. There are multiple of them, we just combine them into one. Okay, let's take a look at some example. This is a real Diels-Solder reaction from literature. All right, so we have this is diene, just part of this molecule. All right, and the second molecule right here we call quinone, which is a natural product usually found in nature. All right, that is your dienophile. Okay, this is a double bond and attached or conjugated with the C double bond or carbonyl functional group and carbonyl functional group. This will electron withdrawing group, and the products, look at that right there. Okay, all right, so my point is the dienophile needs to have an electron withdrawing group. Anything that have double bond, triple bond, anything that can pull electron from the double bond in dienophile. Okay, now stereochemistry depends on the structure of the dienophile. If you start with cis dienophile, your product gonna stay cis, right? You use trans dienophile, the product stay trans. Now, what if your dienophile is a triple bond, is an alkyne? What do you think will happen? Well, if you draw, you can try. You can pause the video, draw it out. Right? I mean, I prefer you do that. When you draw the mechanism, if you remember, we use only one pi bond of the one pi bond of the dienophile. Right? An alkyne contains two pi bond. Well, have two, use one, got one left, right? So if you got one left, this happened. Ta-da, the double bond right there. That's one left. Okay. Now the stereochemistry, if you remember, does this molecule have stereochemistry though? There's two carbon here. But there's no like up and down, not like chiral center like that, and only because of sp2 carbon is flat. Right, the trigonal planar. There's no like point up, point down, not like a tetrahedral like this two carbon or this two carbon. Okay, all right. So we're gonna practice together, draw the product of the a few Diels-Solder reaction on the next video.